So we've been learning how to solve these linear inequalities, and we're seeing that it works much the same way as when we solve linear equations. In this video, we're going to look at some linear inequalities where our variable is being either multiplied by a fraction or it's being divided by a whole number, which is actually pretty much the same thing, just looks different. So let's take a look at a few examples. Let's say we have the inequality x over 4 is less than 1. Okay, well, we saw in a previous section that when we have an equation like this, I generally like to start out by separating the variable out of the numerator. So let's go ahead and rewrite this as 1 over 4 times x is less than 1. And all this does is take away the ambiguity of actually what the coefficient of the variable is. Because if you recall, when we were solving linear equations, we isolated our variable x by multiplying by the reciprocal of the coefficient. Well, here we don't want to make the mistake that the reciprocal of x over 4 is 4 over x. That would be incorrect. So if we separate it like this, then we can more clearly see what we're taking the reciprocal of. And in this case, we'll be multiplying both sides by the reciprocal of 1 over 4, which is 4 over 1. If we do so, this term cancels with this term, so we have x on the left-hand side, and less than, we're multiplying both sides just like in an equation. 4 times 1 is 4, and that's our solution set. So x is less than 4. Let's look at another one. Let's say we have 1 over 2 x greater than 9. All right, so we're multiplying by 1 over 2, or we're dividing our variable by 2, however you want to look at it. And we pretty much approach it the same way as if this was an equation. We're going to multiply both sides of the linear inequality by the reciprocal of the coefficient, which is 1 over 2. The reciprocal is 2 over 1. This term will cancel, which will give us x is greater than 2 times 9 is 18. And that's all there is to it. So when we have a variable being multiplied by a fraction, we can treat it the same as if we have an equation. So we simply multiply both sides by the reciprocal. Let's take a look at the next one. We have x over 3 is less than or equal to minus 7. All right, let's go ahead and separate the variable out of the numerator. So we have 1 over 3 times x is less than minus 7. And to simply isolate our x, we multiply both sides by the reciprocal, 3 over 1. Do the same thing over here. And this gives us, these two terms cancel. So we have x is less than or equal to minus 7 times 3 is minus 21. So our interval solution are all the real numbers, all real values for x, such that x is less than or equal to minus 21. Now notice here this kind of looks different than these two examples up here. We're multiplying, in essence, both sides by the same number, but here I like to use a shorthand form. We're multiplying the entire inequality by the same number. It works the same way. Sometimes I just write it up like this to save space and save time. But this is both the same thing, they just look different. So let's take a look at the next one. Let's say we have 1 over 8 times x is greater than or equal to minus 3. All right, so all we're simply going to do is multiply the entire inequality by the reciprocal of 1 over 8, which is 8 over 1. It's going to cancel this term, just leaving us x is greater than or equal to 8 times minus 3 is a minus 24. And x is greater than or equal to minus 24. That's the solution set for this inequality. All right, let's look at the next one. We have 1 over 6 times x is greater than 0. So what we want to know are all the values, all the possible values. If we plug in for x, will give us a positive number. That makes sense because any number greater than 0 is a positive number. So let's go ahead and solve this thing. We multiply the entire inequality by the reciprocal of 1 over 6, which is just 6. This term will cancel, so we have x is greater than 6 times 0 is just 0. So the solution set for this inequality is the set of all real numbers such that x is greater than 0. So what that means is if we plug in any number greater than 0 or any positive number into this inequality, we will get a number greater than 0 or we'll get another positive number, which actually makes sense. Let's go ahead and do one more just to get a little more practice. I think we're getting the hang of this. We have 1 over 5 times x is less than minus 5. All we have to do is simply multiply the entire inequality by the reciprocal of the coefficient of x, which will cancel the term in front of x. So we have x is less than 5 times minus 5 is minus 25. So our solution set is the set of all real numbers that are less than or to the left of minus 25 on a number line, but not including minus 25. All right, so this is pretty straightforward. We're actually using the same technique, so we're pretending that this is indeed an equation, even though it's an inequality. We treat it the same. So if we're multiplying our variable by a fraction, we simply multiply by the coefficient, and it actually works the same way. We'll look at, in the next section, we'll actually look at one particular case where solving inequalities is different than solving equations, and that's when we'll solve inequalities by using division. So I think we got a good handle on this, so I'll see you in the next video.